Hi class, we're on section 5.1. I'm going to work through the two examples from the handout from Tuesday, December 6th. Here we go. Example 1, the small town in North Carolina is experiencing growth right now. The town's population is growing at a rate of 9.5% per year. We want a function to model this situation. The general form for this function is going to be y equals ab to the x power, where a is the initial amount, b is the growth factor, and x is the number of years since the beginning of the study. Okay, so here we go. Since it's a growth rate of 9.5%, we always take 100%. That would be the amount that they would retain if the population stayed flat, 100%. This is growing by 9.5%, so we add those together and you get 109.5%. So from year to year, this town has 109.5% of the population it had the year before. Before using this in the problem, y equals ab to the x, we're going to need to convert that to a decimal. A is the initial population, x is the number of years. We need to convert 109.5% to a decimal. You move the decimal 2 places to the left, so we get 1.095. That is the formula that we're going to use for this problem. In part B, they want to know the population of this city if it continues to grow at the same rate 5 years from now. So we just take our equation that we got from part A and replace x with 5. You should get 38,569. That would be the population of the town in 5 years. Finally, in part C, they want to know when y, the y value, will eventually equal 100,000 people. So in this one, remember, we don't know what x is. We want to solve for the number of years. 1.095 to the x. We want to find the number of years when y is 100,000. Now, we really don't have a method for solving this algebraically just yet. We're going to learn that later in chapter 5. But I'll give you 4 options. Guess and check, G and C, guess and check. You can keep trying different values for x until you finally reach 100,000. 2, you could use the table on your calculator. You could put the function into y equals and search down the table until the population reaches 100,000. 3, you can use recursion. And that's where you basically type in the starting amount, 24,500, on your calculator, and then hit enter. And then type in times 1.095, and keep hitting enter, 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 enter. Track the number of times that you have to hit enter until you get over 100,000. The fourth and final way that I like is to graph. Go to y1 and put in this function. In y1, type in 24,500 times 1.095 to the x. And then in y2, type in 100,000. Okay, 100,000 will go in for y2. What you'll get on your screen is something that'll look like this. You'll have the population function increasing like this if you use the right window. I would make your x go from 0 to 20 on your window. And your y in your window go from 0 to 150,000 people. And if you put in y2 100,000, you'll see a horizontal line come across. And what we're particularly interested in is this point right here, where the population function in green meets the 100,000 line in yellow. When you graph that on your calculator and find that intersection, you should get to about 15.5 years for your answer for part C.